slides again? This is my first time here.
Oh, it's on an Excel sheet, but I can get your email.
Okay, thank you.
So we have the bulky base first. So I'm going to see if this BR is primary, secondary, or tertiary, and it's secondary, bulky, or actually I don't even have to see that, sorry. Because bulky base is always going to be
Something I don't remember. That's like
E2.
E2.
I have a question.
Yeah.
It's not tertiary? Wait, no, sorry, secondary. It's 2 carbons.
Yeah, it's connected to 2 carbons, this here and here.
Okay.
Yeah. Because when we look at substrate, it's the carbon that it's attached to, how many carbons
Outside of that carbon?
Yeah.
Okay.
Kind of like the complex, something like that.
So for E2 Hoffman, it can either add here or here, right? And Hoffman is going to add to the less substituted. So here, yeah, exactly. Get that. And then for HBrROOR, that's on the table, it's going to be H and Br anti-mark. So Br will go to the less substituted end of the alkene. So it'll be like here. And then OH we said was a small base. In this case, the Br is primary, right? So primary small base SN2. So we're just going to replace the Br with an OH.
I just don't understand the second stuff with the HBR or
Yeah, that'll be on your table. So like,
Yeah, we did the practice questions and
skip
the second
HBr/ROR, and then you'll know it's going to be the addition of H and Br anti-mark.
Sure.
Yeah. Yeah, so anti-mark is going to add the Br to the less substituted side. Mark would add it to the more. It would add it here.
Okay.
Yeah.
How would you know if it's anti-mark or not?
It'll tell you.
tells you.
It'll tell you, yeah.
Oh, you look up HBR and right next to it.
I would look up, so HBr with ROR is going to be anti-mark. If it was just HBr, then it would be mark. But it's all in the table. Yeah.
HBR and
Yeah, both of these will be written, and then you look it up, and then know that it's anti-mark. Yeah.
And you knew it was an E2 reaction because for the first step, because
Because of this. So whenever you see CH33CO minus, that's a bulky base, and you know it's going to be E2 Hoffman. Yeah. Always. For bulky base.
Okay.
So for this, we said it was a small base. It's in the table that I wrote out. This bromine is primary, secondary, or tertiary?
secondary.
Secondary. And normally secondary with a small base would be E2. side sub, right?
Your combination.
Because we said for E2, if it's a small base, it's side sub. If it's bulky base, it's Hoffman. But this is one of the exceptions I mentioned, the stereospecificity. So in this case, the hydrogen here is on the dash, right? And that's the same. So we actually can't add here. And we have to add here where the hydrogen is on the wedge. And opposite. So technically this is like Hoffman, but that's what we have to do because the stereospecificity.
So that's where you would have the R.
Here, yeah. I'll write it down.
And the DR is gonna be something.
Yeah. We still have a method here, so don't forget that.
So that's basically what we're gonna see for chapter 7 in the 10.
Yeah,
You just,
so this part is like chapter 7, and then this is 8.
yeah, so I'm gonna take the hardest part of the chapter 7 is like memorizing each mechanism. E2, because when, for example, for me, when I was, in class yesterday, and he started chapter 7, it was hard because it was so many things at once.
Yeah.
But, like, now that I do it, of course, it's complicated because you have to know what E2 is, SN2, and the SIDA, and the Hoffman.
Yeah, it's a lot of things to like keep note of, but I like
Once you get it
consolidated
eclipsed,
it into.
So let's see, would he ever, instead of a small base, would he ever just put like a nucleophile there?
Just like the word nucleophile?
No, like a
Oh.
nucleophile.
No, I don't think so.
Because then when would we use SN2?
Oh, SN2 we did in the other examples, right? It was, let's see what it was. So we were still given OH minus, right? Which I said was a small base. That's why in the table that I had, I think in that case it was, the bromine was primary, small base, so that was SN2.
Yeah,
Yeah.
because isn't that a good living group?
Yeah,
So when we see a good living group, that would be basically SN2.
I would say for SN2, it's like looking at, it's first recognizing like OH minus CH3O. It's kind of recognizing like the base that you're given. So like for this, you'll always know it's bulky, and therefore everything is going to be E2 Hoffman, right? And then for the small bases, you have to look at whether the substrate is primary, secondary, or tertiary, and then figure out whether it'll be SN2 or.
Oh yeah, because SN2 cannot be the third one. I don't know what to say that.
Tertiary?
No, it can't.
Yeah, no. It won't ever be tertiary.
If we see an OH, because it's both a nucleophile and a base, we have to determine whether it'll be elimination or substitution.
Yeah.
How do we
So
determine that?
if you see OH and it's primary, it'll be, the substrate's primary, it'll be SN2. And if you see and it's secondary or tertiary, it'll be E2. Yeah.
Okay,
Yeah.
that makes sense. But then if it's just like Br, Cl, or iodine, those are only nucleophiles, so they will only be substitution?
Yeah.
I see. So eliminations are always used for bases, and SN, like the N, is only used for nucleophiles.
Yeah.
Okay.
But can we repeat that one more time? Like that.
Oh, yeah.
That the N in SN2 strong nucleophile, and it's like primary, then you assume it'll be a substitution.
So, like OH minus could be a base, act as a base or a nucleophile, right? So if the substrate is primary, it'll act as a nucleophile. And if it's secondary or tertiary, it'll be a base for E2.
Yeah, I think he said that was one of the two tricky ones,
Okay.
OH and RO. He said, he like circled them, because he was like, these can be both bases and nucleophiles.
Yeah.
But then in the category where there's only nucleophiles, I guess those, if you see them, you know it's like substitution. Unless it's tertiary, then you can't do the substitution, right?
Yeah.
Yeah.
So only go to a substitute.
Yeah, I think that is good to note then for OH minus.
Mm-hmm.
For this one, it's on the table. It says addition of two OHs, anti-addition. So, it'll add on either ends of the alkene for the double one. Anti. So where is it? Then you can also do this for the gun. Does that make sense? So if you see this on the table, it says OH anti-addition, and as we said, anti-addition is going to be opposite configurations, right? So one will be on a wedge and the other on a dash, and on either ends of the alkene. Yeah.
These are the actual stuff, but then it's just 2 pages.
Another stereospecificity problem.
And then the next page is proton transfer. And then this one, I think that we will do rearrangement. And then, which is on the textbook, 257. 257. And that's the next, that's where we're supposed to tell you about the different mechanisms.
This one was a bit tricky.
Is it also like, you know, how ER and hydrogen are in the same
Yeah.
wavelength?
But I'll show you what makes this one a bit tricky.
When did we start discussing? When does it matter if I can then use, I mean, we do that separately.
Oh,
It doesn't show.
for E2.
Just in terms of the proton. Because I was in that time when we have
So this is an exception for, you know how E2 with a small base will be Zeitza? So this is a small base, right? Small base, this BR is tertiary. Tertiary with a small base is E2.
Why is it?
Because this BR is attached to this carbon, right? This carbon is attached to this, and this carbon. Yeah, that's how it's tricky. So this methyl group still has a carbon, right? Yeah. So let's see. You can actually redraw this.
It's just this.
Right, so it can't add here because it's wedged, and they're both wedged, right? And it also can't add here This one?
Oh, it's metal, right?
Yeah. So it was written like this, CH3. But you have to notice that like it has a wedged hydrogen, it has the dashed hydrogen. These ones only have wedged because the methyl groups are dashed.
What's the third H going to be?
It could be just like a stick.
How about the bottom CH3?
Oh, this one doesn't count because it has to be on the adjacent carbons to the Br, right? So this is an adjacent carbon, this is an adjacent carbon, and this is an adjacent carbon. Yeah. So this wouldn't count. That's 2 carbons there.
Mm.
Wait, but you cannot make a bond like that, like with Br and H, in between Br and H. That one.
Here?
Yeah, you cannot make it there.
No, it can't make it here either because this methyl is dashed, right? So that means the hydrogen on this carbon is wedged, and that would make both of them
2 wedges,
Oh,
yeah.
okay.
Yeah.
Is this from an exam?
Yeah. This is from the exam I took actually.
Did you get it right?
Yes.
Nice.
Let me see. There's no mistake. I woke up and missed the 1 o'clock, so I'm lost.
So this part is done. Now this one's on the table. It was
So, basically from what I'm getting is, they give you a problem, they give you multiple steps right there. You look at the molecule, you arrange what exactly you're gonna move, then you go through the first step, you go through the second step, and on the more difficult ones, they give you a third step as well.
yeah. Or
And each one of these is
I don't know if I
is
think more difficult, but like it'll just
longer
be an
ones.
extra step, yeah.
Okay, yeah. That's basically the whole thing. Thank you.
So this was adding OH anti-mark, so it'll be on the less substituted side of the alkene over here. Yeah, and that's all for that problem.